So this really is just another practice video. So pause the video pause the video, see how much of this you can go through. This is going to use stuff about Bernoulli trials, geometric random variables, binomial random variables, just the last 2 videos, okay? So let's see if we can put this stuff together and get some more practice. So we have an Olympic archer. They can hit the bullseye 80% of the time, assuming each shot is independent. Okay, we have independence. We know we have either success or failure. Success is going to be hitting the bullseye. And again, you can define success or failure however you want, both in this class and in life. And failure is, it's not just hitting the target. Failure is just not the bullseye. Okay. So we have independence. Each probability is the same. We have only success or failure. These are Bernoulli trials. Each attempt is a Bernoulli trial. So we can use what we've talked about in these last 2 videos. What's the probability that the first bullseye is on the 3rd arrow? That's the probability of a fail, and then a fail, and then a success. This is a geometric random variable. This probability is going to be 2 failures and 1 success. Oh, what was P? 80%. Well, if you have an 80% chance to succeed, you have a 20% chance to fail. So you get 0.2 squared times 0.8. Type that into a calculator and you've got your answer. Dang it. I always keep seeing up how I type this in. 3.2% chance. Remember, we can convert that decimal to a fraction just by moving the decimal place over twice. This is the decimal, move the place over twice, and you get your percent. Now, this is a little bit more confusing. Also, before we move on, I want to make a comment. He's shooting 6 times, but we don't care about 6 times for A. Right? If we're just caring about what's the probability the first success is on the 3rd arrow, we don't care what happens on arrows 4, 5, and 6. They don't matter. So we just ignore them. So for B is a little bit more complicated. The probability he misses the bullseye at least once. Well, let's let X equal the number of bullseyes out of 6 attempts. X is a binomial random variable because we have 6 Bernoulli trials and we're curious about the total. So X is binomially random variable, binomially distributed with N. Well, we know there are 6 trials. Right, this is our N. And P, the probability of success of 0.8. I should have remarked on that in the last one too. Right? X is the number of free throw successes. It was binomially distributed with, there were 10 attempts. Each had a success of 0.62. Maybe I did specify that. I don't remember. So what is this asking us the probability of? So misses the bullseye at least once. We have to unpack that a little bit. So that means we miss 1, 2, 3, 4, 5, or 6 times. Well, that means we hit 5, 4, 3, 2, 1, or 0 times, right? Missing once is hitting 5 times. And X is the number of we're hitting. Okay? So this is going to be the probability that we hit 5 or fewer, hitting at most 5. We can find that with GeoGebra. So there are 6 attempts. Each one has an 80% chance of hitting. We can visually see. What's the probability that he hits at most 5? There it is. See, the boxes are shaded right. 73.79% chance. There you go. Probability of exactly 4 bullseyes is just this. 0.2458. At least 4 bullseyes, well, it's going to be 4 or more. 90.11% chance. At most 4 bullseyes, it's kind of the opposite. 4 or less, 34.46. How many do we expect him to get? What's standard deviation? That's our expected value. It's our mu and our sigma. About 5. We'll say 4.8. We expect 4.8 bullseyes. You could say plus or minus about 1. Or you could say we expect him to get between 4 and 6 bullseyes. Or you could say we expect him to get about 5 bullseyes and maybe 1 more or 1 less than that. A lot of ways to phrase this. That's the idea. Let me know if you have any questions. We did discrete random variables. We talked about their distributions. How can we describe their randomness, all their outcomes and their probabilities? We found how to calculate the mean and standard deviation. We had those complicated formulas and we used those spreadsheets to make it easier. We can use these more quickly. And then we looked at special cases after that. Special cases of random variables called geometric random variables, which are with Bernoulli trials where success and fail are the only thing that matters. Each thing's independent with the same probability. And we finished off with a really special kind of discrete random variable, binomial random variables, which is where we have those Bernoulli trials, those repeated attempts, and we're curious about the total number that succeed. So this is a very common application. You're going to see a lot in the homework. We did a couple in the notes. That's kind of where we're at in this class. After this, we're going to move on to continuous random variables. So also random variables with outcomes and probabilities, but now for continuous things instead of discrete. Stay tuned. Good luck. Bye-bye.